everyone, I'm Arina Husna binti Zulkifli, and today I'll be presenting my project titled Digitalizing the Recruitment Process with Fuzzy Logic, Implementation for Corrosion Engineer Selection. This presentation covers 6 key areas, which are the introduction, literature review, methodology, results, conclusion, and references. Corrosion engineers play a vital role in maintaining operational safety and cost efficiency, especially in industries such as petrochemical and oil and gas. However, current recruitment methods such as resume reviews and interviews are often subjective and inconsistent. Therefore, in order to address this, I developed a fuzzy inference system by using fuzzy logic principles to evaluate candidates in a fair, consistent, and data-driven way. This system was designed specifically for IDMISU Sdn Bhd. Traditional hiring methods have several limitations, which are, first of all, they are often biased and inconsistent. Secondly, it's difficult to evaluate certifications, experience, and technical skills objectively. Lastly, poor recruitment can lead to safety hazards and high operational costs. Therefore, in order to solve these problems, we need a structured and data-driven system. The objectives of this study are, firstly, to develop a fuzzy inference system to shortlist corrosion engineer candidates at IDMISU Sdn Bhd. Secondly, to compare the FIS performance with manual calculations. And thirdly, to generate as a compatible outputs via MATLAB for easier decision making. For the significance of study, this study enhanced the recruitment process for corrosion engineers by making it more objective, consistent, and efficient. By applying fuzzy logic, it reduces human bias and improves decision-making accuracy. It also supports safety, operational effectiveness, and cost control, especially in critical industries such as petrochemicals and oil and gas. For the scope of study, this system focuses on evaluating candidates based on 4 key technical criteria such as academic qualifications, certification, industrial experience, and skills. It is tailored specifically for corrosion engineer positions at IDMISU Sdn Bhd, but it can be adapted for other technical roles in the future. Last but not least, for the limitations of study, this system relies on expert-defined rules and membership functions, which may require periodic updates, but it does not assess qualitative factors such as personality, communication style, or cultural fit. Also, it is currently limited to a single job role and industry-specific criteria. Moving on to literature review. Previous studies shows that fuzzy logic is widely used in decision support system. Language and computing found fuzzy logic effective in candidate evaluations. And SI integration, as shown in recent work by Aditya Sai Srinivas et al., enables efficient batch processing. Next, this flowchart shows how the system works. First, inputs are fuzzified. Then, fuzzy rules are applied to evaluate the candidate, and the result is defuzzified to a final score. This system outputs either accept or reject. The fuzzy inference system follows 4 main steps, which are fuzzification, converting inputs into linguistic terms such as low or high. Next, rule evaluation, applying if-then rules to assess candidates. Thirdly, aggregation, combining all rule outputs. And lastly, defuzzification, which are generating a crisp final score that's easy to interpret. For the input criteria, we use 4 inputs, which are academic qualification, diploma, degree, or master. Certifications ranging from low to high. Industry experience and skills also categorized from low to high. The output is a decision, which are the reject or accept based on the final score. For the candidate data, here is how candidate data is encoded. For example, if a candidate has 3 to 5 certifications, they are rated high. The FIS will return a score below 5, which is reject, above 7, which is accept. This helps human resource managers make quick and confident decisions. This table shows results from 5 example candidates. Candidate 1 scored 2.23 and was rejected. Candidates 2, 3, and 5 scored above 7 and were accepted. This shows how the system clearly distinguishes between strong and weak candidates. Let's take a closer look at candidate 3. This candidate had a master's degree, 3 certifications, medium industry experience, and high level of skills. The fuzzy logic system gave this candidate a score of 8.76, which falls into the accept range. Now, let's look at rule evaluation. At this stage, the system checks combinations of input values using if-then rules. For example, if academic qualification is master, and certification is high, and industrial experience is medium, and skills is high, then result is accept. The result makes sense as the decision depends on how the weights and overlaps are configured. Fuzzy logic mimics real-world uncertainty, allowing more nuanced decisions than rigid thresholds. After applying all the rules, we move to the declassification stage. You can think of this step like mixing paint. Each rule contributes a color, and declassification blends them into one final shade, which are our output score. For instance, if the output is 8.76, the candidate is accepted. If it's 2.23, the candidate is rejected. This makes the result easy for human resource to understand and use in practice. The results show that the system can effectively screen candidates based on measurable fair criteria. By eliminating subjectivity, we support better hiring decisions that align with operational and safety goals. To simplify the process for human resource managers, the system is integrated with Excel. This way, they can input data in spreadsheets and instantly get results via MATLAB with no technical expertise required. To conclude, the FIS successfully structured the corrosion engineer recruitment process. Secondly, MATLAB and Excel integration improved usability. Lastly, subjectivity was reduced, making decisions more consistent. For future improvement, we can extend this model to other job roles, introduce qualitative assessments, and update the rules regularly for accuracy. Here are the references that supported this study, including works by Zadeh, Uhlik, and Ivanov. And that's all from me. Thank you.